Hello, and welcome back to another video where I make a game engine. So I kind of have different ideas, right? This is like localization things, changing languages and stuff. A bit too kind of high up to do now, I suppose. We still have to worry about lots of lower level things like loading levels and tile maps and things, but it's cool to think about. These should probably be like this, even though it doesn't really matter. Yeah, I have a cool... Yeah, I do have a small example, actually, with this that I wrote. Probably should have opened this before. But we have this this local header, where we have the localization class, which is a singleton. It does things. And then we have a locale string, which is essentially... should be more or less a drop-in replacement for the std string, the standard string, and then an example class of just some random text which uses the localization string, and then you can see we have this little macro defined, which is just shorthand for this, and so you can see you just do this. You can specify the ID and then the arguments to format that localized text, and obviously it would expand out to this, which is quite cool. Yeah, so anyway, that's that. I also have these other macros you can see. This is where I got this macro from. I think I changed it a little bit, but I'm going to change it a little bit more, I think, when I actually implement it. This is what I want to implement today, basically, to pretty much rewrite the registry thing that I have at the moment, because at the moment you just have a registry subclass, which in the source file of it, in its constructor or something, you just list every single class that you want to map to a string name to be able to spawn anything from. Whereas with this, you just do it right after you declare the class in the header, which is, one line. You don't have to have a whole source file listing everything and stuff. So yeah, it just feels a lot easier to do. The macro itself is a bit complicated how it works, but it's not actually that bad. If we look at the header here, I'm going to change how the namespaces work and stuff, but currently there's just a base object class, which I'm thinking I'm going to have a registrar interface or something, or just use the current iSerializable interface instead, and just have this work with the serialization stuff. Don't really know, but yeah, anyway, we have a function which we have a function pointer, which is a type, and we map a string to it. So we then have a templated create object function, which creates a new t, the type that we put in, and returns it as a base object pointer. And then that t is going to be called from here. This is going to have a type. So that this function is then pointing to this. And because this doesn't have any inputs, it still works, because this doesn't care about templates or anything. So it works like that. This is then used in the macro here, where we have this macro defined, where we have the type coming in, and this type is then used as the template type in all these things. And because we have a static const thing here, we get this thing, and it will run the constructor here, because we're getting it for the first time, because this is a template specialization. This is essentially a brand new class for every single type that you register. So then this runs every time. It runs the constructor of this, which is here, and it creates the objects thing with the type that you put in from the macro, meaning it will create the correct type each time. And it's actually better than what I did before, because what I did before was I had like an actual object for each of the things, and then I just cloned the object each time I wanted to make a new version of it, kind of like prototypes. This is a lot better because you're just storing a function pointer, and the function pointer you're storing is this. And so, whenever you create this, I think what happens is every time you create this, or actually no, when the preprocessor was doing its thing, all of the correct, like all of these classes are made, meaning this create objects function has a bunch of specializations for each class that you've registered with it, meaning that they will all have correct like memory addresses that you can point to. And so then you just insert it into here, so that then when you call, when you try and find the key name, it will return the function. You can just call the function like so. And so this is when you, this is just like a new object function, which just sets up an object called, sets its outer, calls its create method. I don't know if I'm going to have this create method, but all that jazz basically. And then we have a new object unique, which just returns a unique pointer, which does need its own destructor. You can see here, this delete object is the destructor for it, meaning whenever this goes out of scope, not only does it delete it and call its destructor, but it also calls destroy as well, which does make destroy a bit obsolete, but it's more of just like an example than actual functionality. But this is just an alias, a using alias, where we have a unique pointer, with T obviously being the type here, and then a void pointer with a C object pointer as the input, because that's the object that we want to delete. And you can see delete object has that same declaration. So that's kind of the base of it. I also have things like exceptions and stuff. I was trying out exceptions because I'd never used exceptions before, I'm going to be honest. And SFML has its own exception class, which basically looks exactly like this. And that's what's thrown in the constructor of resource types. So for example, texture, I'll actually just show it. It's quite a lot easier to see here, but you can see that if the texture fails to load for whatever reason, it throws an SF exception. And so then you can try on this constructor and then do a catch for if it fails to load, and it will just be this basically. So that's quite cool, because currently it just crashes if we fail to load a texture, which I don't exactly want. Yeah, it'd be quite nice if I, just printed out something like failed to load it, and then just kept running the game, because we don't want to crash it if a single texture doesn't load. We'll just instead have a white square or something. So that's kind of the plan. I did try and do this key thing with a similar macro where you register keys, so that instead of defining a key in the input manager as saying specifically what its category is, what its thingy is and stuff, you can just say I want to use the W key, or I want to use the left thumbstick Y-axis key, and just put that in instead of having to define the key itself each time. Didn't go amazingly. It kind of works, but I don't know. I just don't really like how it works, I suppose. Yeah, I don't know. It does work, but I'm going to leave this until a lot later. Also, the keys need to be divided into like the constant data with the key. So for example, the device that it's using, the code and stuff like that, and then also the variable thing that changes depending on the context that the key is used in. For example, the scalar value, the dead zone and things like that. Currently they're all in one structure, but they need to be changed into two different structures. So let's kind of get started on that then. I'm going to put this over on the left, put this up here. So obviously our spawn entity, we do have one that asks the registry for the thing. So we get the engine, we get the settings, we get the registry from the settings, and we instantiate like that. This can be simplified a lot by just using the macros. So that's what I'm going to do first. And obviously I do have a, where is it? Serializable interface here. I don't know if I want to kind of keep this or whatever. Yeah, I think I'll use this class. It just makes sense, I think. So we don't need this class registry thing. We don't need this clone method. We don't need this friend. We might need a friend of something else, but we don't need this clone. These serialized stuff can stay. Class name, maybe. Yeah, I'll keep everything else the same. What's this on about? Oh, okay, just a typo, apparently. JSON we need because this is a actual copy, so we can't just forward declare it, which is unfortunate. But hey, that's fine. So, okay, so we need to set up the macro. The macro is going to be located in just this serialization thing, and it doesn't need to be in its own namespace. I suppose it could, but it doesn't have to be. So what I'm going to do is I'm going to have two macros. Like with this, we have the register class custom name, and then just register class, which uses the type as the name, as you can see here. Just because then you can choose which one you want. You can either have the string name be the class name itself, or be a slight alteration of the class name. So for example, you know, these all have I, all the concrete classes have C in front of them. If you didn't want to have that, you could just say, you know, C engine as the type, and then the name would just be engine instead of C engine, and that might be, you know, more readable or something. But yeah, we can say register, actually we want this to be prefixed with tails register class custom name. We want the type and we want the name. Here we go. So we can put this in the namespace of tails, and then put it in the namespace of private priv. And I'm pretty sure this is what SFML does. Is it has SFML as like the top one, and then priv as the stuff that it like hides from you. I don't know if I can probably just do it here actually. SFML, it's SF, yeah. SF, and then there's priv with a bunch of like other stuff in it. Yeah, so you can see SF and then priv, and then this is all the private stuff that you're not really supposed to do things with. So this then uses an anonymous namespace, or a namespace without a name, which I suppose is fine. We can then say template type name, and this would be the class declaration of the serializable registration. So this is the class that's going to actually register the serializable objects. And then we can make another one, and this will be an actual specialization instead. Serializable registration, and this will have the type coming in here as the specialization. So then we can say static const. We want to go out 1. We want to then go into tails, and then private, and then into something that we haven't created yet. Let's just call this registry entry for now. Put in our type, and then call it, should call it reg, yeah. Actually, we should call this m_reg because it's because it's private, we should you know, respect that. And also, I'm using this notation instead of this, where the opening, where the curly braces are in the same line as the declaration, because it's just shorter. And macros, when you do a new line, you've got to have this backslash. So it's just a lot shorter having that, and easier really. So then we can close the class, and then over here we want to actually set it. So we can say tails private registry entry. So this is giving it the default value. So we can say mreg, we should say equals, once again going out into private, and we want the registry entry again of type, and we want to get the static function of get with the name. So we have the class itself, then we have a specialization of that class where we have a member called reg, which is of type s registry entry, specialization of this type, and then outside of this we want to initialize that variable with this value where we get a static reference to this registry entry of type, basically, which will then run its constructor, do its stuff to add the things to the map. So basically all the stuff being static is kind of what makes it work. So we can just define our tails register class with just the type, and then we can say tails register class custom name here. So we want to put in the type, and then we want to hash the type to get the like string version of it. So that's all good. And then you can say, you know, tails register class iserializable, and it's obviously saying can't resolve registry entry because it doesn't exist, but this is what it would expand out into. The specialization being of iserializable, the registry entry being of iserializable, and then the name is iserializable. So yeah, we have tails, private, and all that cool stuff. So now what we want to do is create this registry entry thing, which needs to be in another header. It might actually, I might just be able to do it in the iserializable header actually. I don't know, I want to look at SFML's things actually. It's going to like graphics and then texture, or just text. Does this have like a private, wait, hang on, I go to SF private and go to like copy. This is in private. Does SFML have like a folder called private for all the private like headers? I don't know. I think I might though. I think I might have, you know, include tails and then have a folder called priv or something. Or I could just have it here, because like when are you going to use that when it's not here? The only difference is when you look at this file as like its interface, you'll see a bunch of that stuff at the top and be like, what is this? So it just makes it cleaner that you're just including this random file, and then everything else is nice and neat as you would expect, being the serialization, being the serializable stuff. Obviously, I could make this into its own header as well, which I might. So let's go into CMake and make a new thing. Get to include tails, make a folder called priv, and we want to make a file, call it serializable, let's say, and we can make a new CMake list here as well. Where we say projects, Tails engine, target sources for Tails engine will be public, and we want to say serializable. And then in this CMake lists, we can just say at the bottom here, include priv. I believe it's include. Let's have a little look here. Add subdirectory. It's not include at all. Add subdirectory. There you go, priv. Cool. Yeah, priv will be fine, I suppose. Open this in Notepad, please. If not defined, tails, priv, serializable. We want to define it. Say namespace tails. Actually, namespace tails priv, I think is just fine. And then that is just fine there. So I think that works. And we can CMake again. Go into Tails game. Now we have this priv folder with our serializable header. Cool. Okay, so in here, we can. Actually, I'm just thinking we do just want this. We can then say class iSerializable, and then have another namespace for priv as well. I do want this to be down one. So we should probably then do this just so we know which namespace is which. There we go. So now we want to have the function, so we can say create serializable func. This is all like private stuff, so obviously it doesn't matter too much what I call it, but serializable, we want to have it be, you know, just a function pointer. Yeah, normally if you type def, you want to put this name in here. So if you did a type def, then it would be that instead, but because I'm doing using, just because I prefer it, that instead. I can comment later, so then we can say using serializable registry. Actually, let's say serializable map will be a map which we need to include. Be a map of strings to the create serializable functions, and this will also need to include string. So now what we need is to create a function. This will be inline because the definition is in the header as well, and we want to return the map. Get serializable map here. I'm going to create a static serializable map object, call it registry map. Just return the registry map. Actually, we can say get serializable registry instead. So now this is our templated class. No, this is our templated create function where we return an iSerializable. Say create. We could just call it create object, honestly. And then we can just do a return new t. Yeah, we want to make sure that it's. What am I doing? Static assert. Say is base of the base being iSerializable, this being t, and then if it is not, we want to say cannot create objects. It does not derive iSerializable. I'm going to add this to the dictionary because this is annoying. Okay. This is going to say it's not standard or something. Yeah. Right. So obviously you could return a unique pointer or whatever. For now, I'm going to have it be a raw pointer. Just because creating other stuff might want a raw pointer instead of an owning pointer. I don't know. But, you know, that's all fine. So this is where the class comes in. We have a type name of T. We can then say class, or actually we have a struct. Yeah, we can just use a structure instead. S registry entry as the structure name. And we don't want to be able to copy it, so we can delete the copy constructor and then delete the copy assignment operator as well. And then we want a public get function, which will be static, obviously. We want to get it. We want to get the name of it. And then we can say static s registry entry. Just call it instance. And in the constructor, we can pass in the name. And then we can return the instance. Now, the issue is, obviously, we don't have a constructor for this. So we can make a private section. And because we don't want anything but ourselves to create this object, we want it to be private. As we can say s registry entry, pass in the string as a name, and this is where the magic actually happens, where we add the object or whatever to the map up here, to this object even. So we can say serializable map registry. We want to set this to be the get serializable registry function, meaning now we have a reference to that registry map object. Our create, I'm going to call this create object function, just because create object func. Rotos, other factors, conflicts. Okay. Cool. Create objects func is just going to be called function, and we're going to set this to be create object of type T. And now we want a pair. This pair is just going to be the result of the insert that we're going to do, so that we can check if it was successful or not. It takes a serializable map, an iterator of that as the first one, and then a boolean as the second. The iterator is the first, I think, is just where it was inserted. Let me put this result, and this will be the reg.insert. Yeah, the registry.insert. We want to insert the serializable map value type, and we just want to create an instance of that. This type being a pair. The two values of this pair is obviously string, and it's the string and the create object function. So we want to pass in the name for the string as the key, and then the func as the function value. Oh yeah, we can just ignore that. We don't need that because it's implicitly done here. So that then means that we can then check if the results second, which is a boolean, if the result second is invalid, then it's failed to, you know, go in. So we can just return or something. I'm going to also actually include the debug. And then say cdebug error. We can say objects ID and then name is already registered. Just like that or something. Otherwise we can just do a simple print and say registered ID name of type, and then we can say type ID of t dot name. Now I don't actually know which one is standard and which one is just a Visual Studio thing, and also just because why not, I'm going to say of size as well. Say size of t. So yeah, so we're printing the ID, the name, what its actual type is, because this is, you know, for the actual type. So this will get replaced with, like, you know, entity. We can say what is the type ID of entity, and then name, stuff like that. So that's quite cool. So now we actually have this. We can then go back to our serializable here, which was complaining. Yeah, it was complaining that that thing doesn't exist, obviously. So what we can do is just include it as serializable here, and now it works just fine. So I believe that is more or less all we need to do, apart from obviously having friendly functions that the user can see and use for things. So for example, if we want to actually create an object or something, we need to create a function for that, because in here, for example, we have that, and this kind of thing, we just get the name. We can then query the static object and stuff. So what we do there is just in the object we can have a generic one, and then in the level we can have an entity specific one and stuff like that. So in here we can say, you know, return an object pointer, say new objects. We can have the string name. Include string, and then we also want the outer as well. So here we want to include the tails. Yeah, the tails private serializable, and then we can say priv get serializable registry, although we actually just want to get the serializable map. We can just say auto, actually, can't we? Auto reference, call it registry, is going to be the priv get serializable registry, and then we can say we can probably auto this as well, call it its, because this is going to be the registry iterator, just call it regit, priv of, no, we don't need that, we can just say registry.find. Yeah, find the name here. This is going to be red, non-constant value. Oh yeah, it needs to be can't be a reference, because this is not returning a reference. So if the regit is equal to the registry.end, meaning the name is not part of that map, then we can say debug error object name does not exist in registry, in the registry, and then we can just return null pointer. However, if it does exist, we can then just do our default setup stuff. So we can have our result, and we want to say we can do a dynamic cast to object pointer from the regit dot second, which we want to call as a function. So this is going to say serializable to objects, because it's incomplete. So we can just include tails serializable, and then we also don't need to include this. Now, I don't actually know if this will work. But actually no, because objects I think are going to be serializable by default actually. Or they're going to have the ability to be serializable by default. I think that was what I had in my mind with this. Was yeah, because the serializable interface doesn't have anything to do with object here, so include serializable and do that. This then obviously doesn't need to do that because we have a virtual destructor here. This doesn't need to exist. And then do I need to implement these? I don't think I need to, but yeah, we can then cast to it completely fine because object inherits from serializable, and then that also means that the entity and stuff shouldn't then inherit from serializable because their parent does already. We can deal with other stuff later. Okay, so now we're casting to it. We have a result that is of type object pointer. We can then say the result outer is equal to whatever outer the user passed in, and we don't have any kind of create method, so we can then just return the result. So now we have a simple new object function, which is based off the string name. That's very nice. Yeah, I think I am going to have a type of unique objects where we could just say template type name t using t unique objects, and then we can just say unique pointer to t, and then the destructor can just be, what actually is the default delete of this? What does it do? So it just does the array delete. Because obviously default delete only has to have the operator here. Oh, hang on, we have two default deletes. We have this default delete, which just does this, and then we have this default delete, which has an array. Okay, so we have a normal default delete and then an array default delete. Obviously this doesn't care about arrays, so we can just say delete objects, the object to delete. We can static assert the size. See if 0 is less than the size of objects. I don't think this will work because obviously this is runtime. Suspicious usage of that. What about that, huh? Nice. Suspicious comparison of size of. Whatever, who cares? We can just delete the object. If you want to do anything beforehand, we can, but probably not. I'm not going to have it be const because I might do other stuff. Yeah, right. So this will just have the void pointer, which will take in a C object pointer. And this will be, yes, this is our deleter. So then when we have a unique object, obviously of type C object, we can say new object, unique, have a string as a name, and the outer. We can just have this be a wrapper for this function, where we can just return the new object with the name in the outer, and delete objects as the deleter. So this will get called whenever the destructor of the unique pointer is called. Now, I don't know if you can static assert this to make sure that T is a subtype or a subclass of objects or not. I don't know if you can do that. It'd be cool to, but I don't know. I don't care. Right, if it's not an object, then that's their fault. It literally says T unique object in it. So I can't be bothered. Okay, so there you go. We have some basic things going on there. So let's see if this works with the entity. We don't need this, obviously, and we can go into its source and delete this clone as well. Here we go. So now what we want to do is say tails register class C entity, and it will just do its thing. Great stuff. So now we have this. It's called C entity. You could say custom name and then say entity instead. And now this says entity, but this is still using the class C entity, so doesn't really matter. I'm going to have it be C entity just because then it's all, consistent. So yeah, now we're doing that. So in our level here, this is obviously saying it's marked final, but it's abstract because we don't have the serialization stuff done. That is obviously a downside, but so we can have our serialization things here. Serialize. We can just return an empty object at the moment, and then deserialize. We don't even need to do anything for this. Obviously that's a typo, just add it to the dictionary. Okay, cool. So now this can be created and be final. We just want the spawn entity things to work. So this is fine. This can be the same thing. It's the implementation is fine as well, because that just takes in an object. Now the issue is this spawn entity function here. We want to replace this with a call to the get serializable registry. Actually, no, wait. I can't even remember what I did. What did I do with the object? We find the name. So I think what I want to do is instead just say new object, unique, say, yeah, we can pass in the class name here, and then say this as the outer, and then pass in this. Now the problem is this is obviously going to be an object instead of a entity. So once again, we can do some cool things. We can make a templated version. We can say unique object T, new object unique of type. It's a long name, but it works, I suppose. Like so. And this will simply just return a new unique object with the delete object deleter, and we want to take the new object unique of name and outer, and we want to release it, and we want to cast this to the T, like so. So it's all done in one line. It's a bit weird, but we create the unique object, we then release it, meaning this unique pointer doesn't own the memory, it then gets cast to the type, puts straight into this unique object, and then that's all chill really. I suppose we don't even need to do this, we could just say new object instead, and that'll work just fine. But yeah, we can then static assert this, say is base of the base to be, what do we even want the base to be? We want the base to be object, don't we? Cannot create objects. Yeah, cannot create objects. Template type does not derive C objects. There we go. There we have that. Obviously we could have a templated raw pointer one as well. Might as well do that. Very similar thing. The object of type. Get our name. Actually, I'm thinking we could just use a string view here, since we're not setting it. Although, oh, there we go. Just do that, because this wants a const string. This returns a const pointer. Seems to work just fine. Sick. Let's change these to string views then. Can we make const? Yeah, whatever. String view, string view. This could be a string view. This could be a string view as well. This can just return just dynamic cast to T from new object. Once again, assert it. Although now I'm thinking, instead of doing this, we can just say new object of type, and then say T. So this function wraps this function wraps this function, which wraps this function. So yeah, it's kind of cool. So now in our level we can just say of type, and we want the C entity. Now this is going to complain because obviously it's not a unique pointer. Oh yeah, because our unique pointer thingy is needs a specific destructor. So I'm not going to do a unique, I'm just going to say of type, and then wrap this in a make unique. No, not make unique, just a unique pointer instead. So this gets implicitly upcasted to C entity, even though it is of type. Yeah, no. Yeah, so it it gets upcasted here, put into a unique pointer of C entity, but the actual value is what it should be because it's created with that templated function called create object. So obviously we don't need this anymore, we don't need the registry anymore. I'm going to keep debug there just because it'll be useful. And now nothing changes here apart from this engine being abstract now, because obviously serializable things, the world is abstract as well because of serializable things. This, return that, deserialize, nothing. The world will have the same thing. It might be useful to have deserializable as well. I don't plan on really having any functionality in these things, but it might very well be useful. Yeah, I don't know. I don't know if it was a good idea to have objects inherit from serializable, but I suppose it doesn't matter too much. It just makes it a bit easier for the casting and things. Although I think dynamic cast can like side cast or something. I think it's very versatile, but anyway, and then our world is done, then our levels are done, our entities are also done and things like that, so cool. So this should work as it was. I did also fix the game opening the wrong thing and stuff, so I can just launch it from here now, and I think it should work. Oh yeah, because I did CMake again, it brought the master down. Okay, we have things, clone. Oh yeah, the class registry. Let's just delete the class registry files. We don't need them anymore. Include class registry. Does this inherit from anything? No, it is literally just that. Okay. Class registry, get rid of that. We don't have any, normal registry things, do we, apart from engine registry? Don't need that either. So now our class registry, well, engine registry, get rid of that. Class registry, get rid of that. As well as in the source file, we don't need class registry. We don't need engine registry either. Okay, nice. So now there'll be compile errors with including stuff and things, but those will be easy to sort out. So for example, in our engine, I feel like this will probably include stuff. Yep. Doesn't seem to be any issues here. Obviously the engine settings will have issues, or not. Yeah, it's got registries here though. We don't need these registries. We don't need this. We don't need anything to do with these registries here. We don't need this. We don't need these includes. This then isn't implemented, obviously, because it doesn't actually need to be. Okay, does the engine have any weird stuff happening again? No. Let's just play it and see what happens. So we have the widget viewport, cloning, don't need that. Container, widget, inherits from objects, we don't need the iSerializable. We have serialize and deserialize. If we play again, we now have the vertical container with the thing there. This clone doesn't need to do anything. We might have a clone method eventually, but don't need it at the moment. So text has a clone method, don't need that. Okay, cool. We have our thing where we were able to create an entity based off its name, class name C entity, from our static map. And so if we were to then say, I want to spawn C player, this wouldn't work. It might give us a seg file or something, but it wouldn't work. It says error object C player does not exist in the registry, because that was the error thing we did. It obviously gives us, it crashes. I don't want it to crash, but this is because of this. So I think we want to check if this returns a valid thing or not. Call it result, and just have it be this. And then we can say if result is invalid, return null pointer. But if it's valid, then we can do a move on result. So now if we run it, it should. Well, it might not still, because the return of that, I don't know. We have main, this is doing stuff, obviously. Oh yeah, we don't know it's outer as well. No, we do know it's outer. We do. Interesting, but anyway, you know, it. So that doesn't work. But if we go to the player thing here and we say Tails register class, the C player class, it doesn't work because this has already been declared with different type const. Oh, interesting. So it's saying that even though this is a specialized C player one, because it inherits from entity, the entity's already been declared. Wait, does this not work with inheritance then? Oh, that wouldn't be good. Okay, so apparently even though so it's not inheritance, it's some other thing. Even though player doesn't inherit from entity, it's still saying that it's been, you know, set as entity instead. So maybe it's not an inheritance thing, maybe it's just because the name is the same or something. Maybe if we do this instead. This template thing was supposed to change that, I think, because obviously this is technically a different type because it's got a different template thing, but anyway, this is, it seems to work it out now, so it's strange. But I don't know why that was working just fine in my tests then, because obviously here we have, you know, this entity, we have entity 2. They're both getting registered. This is obviously of type C entity. This is of type C entity 2. And they both have the reg variable name. So I don't really know what's going on with that. But, you know. Oh, wait, no, it's because it's a. Never mind, I'm just an idiot. It's because it's a global variable. But we need to have. I did miss out something kind of critical. Where is it? Here we go. This. It's because we need to specify that this registry is of is in this. Currently, it's just saying that this is a global variable instead of being a variable inside of this class. That's the defining factor. Our serializable registration with the template of type. That's the defining factor here, meaning this now works without having to change the name of this registration thing. And it's part of this class instead of the global namespace. I was just being a bit stupid. So there you go, that's that. And now it should work just fine, spawning the player via its name. Yay, we can spawn the player via its name. And then that also means, obviously, that we can, go from JSON. We see that the class is cPlayer, and we just spawn it via its name from JSON. So that was kind of the whole idea, is making it easy to spawn stuff from JSON. Meaning we spawn stuff from JSON, we can then, we can then deserialize it via a JSON object via that method. That deserialized thing just takes a JSON object, and that's kind of, you can then just set the members from this object. This object is that object that created this, essentially. So there you go. That's that. So that was that. I want to do the keys now. We've done this big kind of nice registry thing. Let's do keys. Go back to the input manager here, where we have just a key, but we also want so we have the key, but obviously this is going to be changing based on whatever. So the kind of main idea is to have these two as a single structure, and then be able to have the W key, or the gamepad face button bottom key, kind of defined as like objects that you can just call almost like an enum, and then say, I want this key, and then these will be the variable things based on whatever your game requires. I'm not going to do that now just because I don't need it. I don't have the thing set up for that, and it's fine to just set these each time anyway. But what I do want to do is look at this is scalar boolean, because currently the only place it's used in this entire library is here. And what I'm thinking is, can we get rid of this boolean to then just check if the get access position is equal to 0, and if it is, treat it as a button press instead. So we can cut this, do an auto for access value, say if access value is greater than 0, should probably say the absolute of the access value is greater than 0, then we can return the access value doing all that. If not, then we can just if not, we can then check if it's a button press. And then break if that's false as well. So so we check if the absolute is so we check if it's not 0. We don't even need to do the abs, actually. We can just say if it's not equal to 0, meaning it has a value, then we treat it as an axis. Because obviously if the axis position is 0 because we're pressing a button, then it doesn't need to thingy. So if we play it, I have my controller here, we can move up and down and stuff. We can also go on the keyboard. I don't have an actual key done though, because obviously the D-pad is an axis, so the axis thing works, but we still need to do the key things. So let's get the input manager, add action mapping. Let's call it jump, even though it's not actually jumping. We want the input device to be controller, and we want a Xbox button, and we want to be A, let's say. And then we can say in tick movement. Actually, no, not in tick movement. We just do it after. If the input manager is action active, jump, then we can. I don't know. We can just move left, let's say. or move right even. Like speed or whatever the thing is, base speed. This will be A. And we have nothing. We have the thumbstick doing stuff for some reason. I want to have this be LB. LB. This will be left shoulder, won't it? And then right shoulder. No. LB and RB. Wait. What? We have left shoulder and right shoulder here. Select start. What is LB and RB then? Oh, is that the left thumbstick button? I want to give these actual, recognizable names because I'm getting confused with these. Left thumbstick button. Right thumbstick button. Okay, so we have, better names for these. So, I think obviously the issue is the thumbstick probably has the same code or something as a button. Because, the axes and things are treated differently to buttons. Right? So, if we do a check for if this returns a value, our problem is if the code is 0 for the button A, that could be the same code for left stick X and Y, which is what it is, I think. Meaning this is still checking for X and Y, for the X axis of the left thumbstick. How do I fix this? Scalar Boolean. Honestly, I don't know if there's a way around this without the scalar Boolean. But if we go back to the game now after doing that, still doesn't work. You know what? It's because I didn't do the thing. I'm going to change the source to relink the library. Anyway, it still doesn't work with the A button. So let's go all the way back here. Relink. And the A button should work again. Yeah, thumbstick doesn't, the A button does. So there you go, that's the thing. So even though we do just have a random Boolean here which is used once, well it's set once and then got once, it's still critical, so I'm gonna leave it there. I was also thinking of doing an animated entity. And instead of having like an animation player or things which you can add to different things, I'm just thinking having a subclass of entity being like a sprite entity, and then a subclass of that being an animated sprite entity. Just because I'm already doing inheritance, I might as well go full on in with it, and also using an animated sprite. I don't know, I feel like with the architecture of this engine, it just makes sense to have it be an entity itself. Also, yeah, I think reading inputs from JSON would be quite cool. I might do that now, actually. Where the input manager creates the actions from whatever JSON. Say load from file or something. So we have our file name here. We want to get our input file stream. Call it file. Let's just say file name. This is going to say it's incomplete. So we want to include the fstream header. So it's saying it needs an actual string, not a string view. So unlucky, we're going to have to use a string instead of a string view. That's fine. Here we go. We can then get our JSON objects, which we need to include JSON for. Call it input objects and get the file name in here. Actually, I'm going to do the same kind of way I did it with the engine because I don't want the weird array thing that happened there to happen here too. Where is it? This where we just set it equal to the pass. We do need to pass, yeah, unless this is fine with just being saved to a string though. Basic JSON. We have value T, we have null pointer, we have compatible type, we have basic JSON type. Initialize the list. And then that's it seems. So it doesn't seem to be string. I'm going to do a pass anyway. Just to be safe, pass in the file name. So now we have our input objects. We can check if it's valid. If it's not valid, then we can just return. If it is valid, however, we want to loop over we can do this. Say, well, actually, what I have here is I have this thing called mappings. I'm thinking, however, getting rid of this, just having these, so we just loop over these objects. So we'll do that. So each of these will have a key because it's an object, and the actual object value, which is the array. So we'll have the action name, and then the mapping array. This is because we need to loop over the items. Here we go. So for each item, we want to, I don't know if I go to the, where is it? We want to add an action mapping with the action name in here, and then a list of keys. So we want to loop through, let's call it mapping objects, the mapping array dot array. So for each item here, we want to construct a key. So we can say std vector this key, call it like keys or something. We can then pass in keys, and that's fine because this tries and places, so that's fine. But yeah, this is getting copied into this object anyway, so that's all good that this is local. But yeah, it should be made static. So here we can then just say keys dot in place back, and we want the input device to be whatever. Actually, we can get that from a string. Input device from string. Very fancy. We want the mapping objects at device. We then want the code, which I'm not exactly sure how we're going to do this. Just say 0. The scale multiplier, we can just say mapping objects at scale multiplier dot as, wait, what is this returning? Oh, get, here we go. Get as a float. We want to get as a string. Here we go. And then things like dead zone and scalar and stuff. We can also just have another constructor for that. Ambiguous, obviously. Let's have these not have defaults, so it's not ambiguous. And then here we can simply say, I also just want this to be an input device. I don't want it to be an int. I just want it to be an input device. Or do I? Yeah, no, I don't, because this just sets it. It's only there to do a simple cast for you, so I don't need that. I can just say in device. So we have device will just be in device. Code will just be in code. Scale multiplier will be in scale multiplier. Dead zone will be in dead zone. And then in is scalar. It just is scalar actually. Will be in is scalar. Like that. Now down here we can have the rest, which will be the dead zone, where we say mapping objects at dead zone dot get as a float. Say mapping objects at is scalar dot get as boolean. Nice. So now this will just add all the keys. Obviously these might not have values, so we've got to be careful, but that'll be done later. We get all the keys. Is this not the right way to get an array? I don't know. Anyway, yeah, and then we just add the action mapping there, then move on to the next action mapping. So I'm not going to test this now. We can test it when we need it, but it's good for now at least. So yeah, one more thing I do want to do is try making the localization string, just because I think it'll be fun. Yeah, that's it really. Yeah, so I do have an example of it here as well. I think I showed this earlier, where we have, actually before I do this, before I forget, I want to do exceptions and stuff with the resource manager. I want to try and catch and stuff, because obviously with our create resource here, this here might throw. So we want to try this And if it fails, we want to get a const sf exception reference, call it E, let's say. And then we can say debug. We don't have included. Error. Fail to create resource exception, and then e.what. And then we just return null pointer, because obviously we don't want to return the get because it won't exist because it's failed to replace it. And obviously I assume we can clean this up a little bit by having it all on one line. But yeah, and then this doesn't need any tries. So that's the try except thing. Cool. If I run this, should all just work still, I think. Never mind. Oh, obviously, because it's an illegal case. Because device is not an integer anymore, so we don't need to cast it to an int. We can just straight up use the enums. That compiles fine. Still need to link it though. There we go. Now we're linking it. So that's cool. So now if we try and load something that doesn't exist, so for example in the player, the load resources here, if we try and load, player2.png instead, then it shouldn't crash. It should instead just catch it. There you go. So it still runs. It just didn't crash this time, which is what it was doing last time. So failed to load image, still prints that. And I have my own error, which I suppose I don't really need, but it's kind of there anyway, because why not? So yeah, great. Now instead of crashing it, just prints an error, which is good. I don't want it to crash. So now we can try and do localization things. Yippee. So let's create new CMake stuff. We can make a new file, call it localization, I suppose. So if it's not defined, Tails localization, then define it. Put it in the namespace of Tails. Include our Tails config header, and just make the class quickly. Nice, and add it to the CMake. Then we can get our source, just do the same thing. And obviously then CMake. Okay, nice. So we have that. We also want our locale string as well. Okay, now we have that. We can CMake build again, or just CMake. Now that's done. We have our thing, and we'll have our localization and stuff. Here, the headers are apparently not found, even though they're right here. I don't know what's up with that. being found in the files. It's just not in this thing here. So I'm going to close and reopen it. There we go. Okay. I'll put all the headers on the left because I prefer it like that. Close the other files I have open because I don't need them. Okay, localization things. Localization is interesting. It's a very interesting thing indeed. So let's. I believe I just have it in one header here. So for the localization class, this is going to be a singleton. We're going to have something called a locale map, which is just literally going to be a map, which will map the key. So like the key of the kind of thing that we're going to localize. So for example, we have a key of like play_game, right? Like this, for example, this is our key, and this is then going to be mapped to something like, you know, play game in English, right? I do have the example here. So we have, you know, play_game, play game, but in French it will be this. I don't know French, but yeah, I was using Google Translate for this. So you know, this is quite simple for like, you know, plain text and stuff. But what if you wanted to use a number in it? It's like, you know, you got this number of items. Well, you can use formatting. You can use the new C++20 format text things to do format stuff, and they also support ordered formatting, which makes our lives a whole lot simpler, because then you can say, you know, you got 0 items in, you know, this time, right? However, if French was, you know, you got in, you know, one time, you know, this number of items, this has 0 first and then 1, this has 1 first and then 0. Without the ordered like formatting, if we had 1 item in 2 time, this would say you have 1 time in 2 items. But because it's ordered, we have 1 item in 2 time, 2 time in 1 items. So, you know, yeah, the ordered stuff just makes it a whole lot easier. So we could just say we want a map of we could say we want a map of string to string, right? Obviously, because we have the string as a key and then the string is an index, or the string is a key and the string is a value. But obviously string-based lookups and stuff, they're a bit slow because you're comparing strings. So we hash the string into an integer, right? We hash it into an integer. Nice and kind of easy. Yeah, I'm going to say, you know, using... Actually, no, I'm not going to do that. We can just use an int, right? Yeah, so I'm going to have a private section, because this is going to be a singleton, because we want to be able to access the localization stuff from anywhere, basically. And also, like, load the files anywhere and stuff. We can quite simply just have a private default constructor so that other people can't create this. Have our static get function, which will return our static instance. And then our variables are locale map. And we can have another one for our current locale. I'm not going to do that now though. But yeah, we can then have a static variable to return the locale map. Call it get locale map. Just return get.mLocaleMap. So we want to first have a function called getLocalizeString, which will take in our ints as the ID, where we want to return the get locale map dot at the ID. I will make this constant, which means I'm then going to need to have. Oh wait, no, I can't make this constant anyway. Never mind. Yeah, so we can get the localized string with our ID, meaning it's just a simple lookup into this. But obviously, this isn't very user friendly, right? We want to be able to input, the actual key as a string that it would be seen in like JSON or whatever. So we want to return. We can overload this with a string view version for the ID. But how do we go from string to int? Well, for that we have a hash function. We can make it constant expression. We return an int, which will be the key, and we just hash a string view. And then we can just return 0 for now, right? But this will be like, you just convert each thing into a character. I don't know. It's some kind of hashing function, which means that when you load a localization kind of table or whatever, or like JSON from file, you would hash all of the keys into this, then set the strings values, and then when you want to get a value, you can just hash your thing. And because the hash is going to be constant, the same string going into it gives the same integer coming out. It's just going to be an integer lookup plus obviously the hash. But yeah, since it's a constant expression, it's quite fast. So then here we can just say return the get localized string, but we can do a hash on the ID. So this function wraps this by using the hash. Yeah, and then obviously we can have a static rule for the load localized strings, where we want a string for the file name. We can't do a string view because obviously the F stream doesn't like that. Also, I'm doing everything in the header. I do have a CPP file here. I don't know why I'm doing everything in the header. Let's move everything to the source file. I don't know why I'm doing everything in the header. Does this need to be... Wait, what? Okay, fine, I'll do it myself. I don't know if the constant expression needs to carry over or not. Do you have to have an inline function for this? Do you? Okay, it does have to be inline, which is fine. Yeah, it doesn't matter that much. So then obviously we can, include fstream and JSON here. It's all fine. Stream will say, file. The file name, we can say JSON. Locale objects is going to equal to JSON pass the file. Also, I just realized I think in the not the resource manager, in the input manager. I just realized I think I did this. Yeah, I did the file name instead of the file. There you go. You pass the file because pass, this does that. Anyway, I just realized that when I did this, I was like, make sure not to pass the file name because it's a string. Anyway, we can just return true. We can fill this out later. Yeah, so this would just go through a file, go through all of its members. Actually, no, we can do it now. We can say for each member, we have the lock key and the lock val, and we say locale objects dot items. We can then say for each item we have, we can get, actually we can just say locale map reference lock map equals get locale map, just so we don't need to keep calling this function each time. We can then say lock map dot try and place the lock key, no, the hash first, the hash of the lock key, and then the lock val dot get string. There you go. We can check if the lock val is string. If it is string, we do that. If it's not, we skip it. If locale object dot is null, return false. That's another thing I don't think I did, was checking this correctly. Yeah, dot is null. It's supposed to be not just checking the object. Yeah, so I think that's fine. I think this might do a thing where it's if the file dot is open, if it's not open, then we return false. I think that's another thing. I don't know, but I'm gonna do that here as well. I might just create a general interface for this stuff. I don't know. Also, there should be a boolean. Okay, cool. So, right, we have this. It adds the localization stuff, the map and things. Obviously, this try and place will return an iterator for if it succeeded or not. I don't really care if it succeeded, I don't think. But anyway, so now we have this interface for loading a locale, doing the map stuff. Yeah, we also want to say lockmap.clear as well. We want to clear whatever is in the lock map already. Before looping through. Okay, so now we have that, we can move on to our locale string. Our locale string is going to be a bit more complicated, but it should still be somewhat simple. It's meant to be a wrapper around a normal string. But also gives you the ability to say, I want it to use this ID for the localization table map thing. And then it just gives you the translation whenever you want it, really. So start off with the private members, let's say. We want the ID and the string. And that's all the members it will have, I think. So we can have a we can have our constructors. Our first one's going to be default. We can then have, no, I don't want, I want the locale string, not the one I have to include. We then have our, simple std string things where we set our ID to -1 because that's an invalid thing, meaning it's not localized. And then we set our string to move the incoming string. We can then, no, I don't want that. We can then have our const char, meaning obviously overload similar to a normal string. We can then just call this, but create a temporary string via this, like that. We can then have our templated one. This will be for formatting it, because obviously we want to be able to format the thing, as I mentioned earlier, the localization. For actual values, you want to be able to format it. This will be the constructor that formats things. We can have an integer for the ID, and then the args. We can say our ID is going to be ID, and this string is going to be, well, actually we can, no, this does have to be in here. We do have to have this included in here instead of in the CPP, unfortunately, but we can include our format. We have v format, which means we can pass in the localization here, which we do need to include in here. We want to get the localized string of ID, and then we can make the format args of just unpacked args here. Like that. And then since our string and int are both trivially copyable and movable, we can just default these. There we go. So now onto the interesting things. So obviously we want to be able to set the ID that this string is using for the localization. And I want to be able to, I don't want to have loads of like overloads and stuff. So what you can do is it'll return the integer that has been hashed. So locale ID, we'll take a string view, and the args here, and we can set MID equal to the hash of the ID that's coming in, which also takes a string view, and then we can return MID. I do want to do other stuff as well, but we need to actually implement the functions for that. And the one that we're going to use is this next one, which will also have arguments, because we want to provide arguments for more or less everything, just in case you want to format it. You don't have to actually, input any arguments if you don't want to. So we can update locale, which will just have the args here, and this will just fetch like the freshest localization thing. So if you are wanting to change localization from like French to German on the fly in the game, you can just call this on every single bit of text that you want to update, and it will just update it. Yeah, you're probably gonna want to restart the game when you change localization anyway, though. It's not that big of a deal because you only really do it once, because it's the language you play in. It's not like you change it every now and then. You do it once because you want to change the game from English to German because you're German. Why would you change the game to another language after that? So yeah, I do want to make another function quickly. Making a no discard getter. It's not really a getter, but it's if it's localized or not. And we can simply return if MID is less than 0. Actually, no, if it's greater than or equal to 0, then this will be true, meaning it is localized. So we want to see if this is localized or not. Because if it's not localized, then we don't want to get the freshest thing because our ID won't be valid. So we can set our string to be the localization, get a localized string from our ID here. And then we can also see if the size of the args is greater than 0, because we don't want to do this if it's not greater than 0. Then we want to call a format function. But up here, quickly, we're going to say update locale. We want to forward the args into it, and then we can create our format function. Which will actually do the formatting. Yes, this update locale primarily does this, but if you have any arguments, then it will format the string as well for you. This format doesn't get the latest one, it just does the formatting. Set the string equal to the v format of the string, with the make format args being just the args. And this yellow line is just because this isn't forwarded in this function. I think we could probably just use normal references, normal L value references, instead of R value, which is what this is. But I don't know. It's also going to be like very basic types as well. It's going to be like int and string and stuff. String's going to be the only like large type. So I don't know. I think R value's fine. I don't think it matters that much if we're missing a forward. But anyway, if we are greater than 0, then we can just format, and we can forward the args into the format function. This is still complaining that it's not forwarded, even though it is forwarded, but I don't know. Anyway, so the format just does that. And then the rest is just simple getters and stuff, really. So have a no discard for just getting the string objects. We also have a no discard for getting the locale ID. We don't care about like converting it back into a string, or like unhashing it or something. We don't really care about that because you're not really going to. You don't really need to do that. But then there are also, since you're treating this like a wrapper to a string, you want to just be able to set the string. Like for example, it should just be a drop-in replacement for string as well. Like you don't have to use the localization part of this if you don't want to. So because it's not that much bigger than a string anyway, because it's only got an int. It is a string just plus an int, so it's not that bad. So we can just say set string. can have a string view. For the string, we also actually don't want this to be t, we want this to be args t. I use args t just because it makes sense to me. And then we want to check if it's localized. And only if it's not localized do we then set the string. We don't. If it's localized, we want it to be read-only. So if this has a valid value, we want it to be read-only, basically. So that you can't accidentally set the string to something else that's not localized when it is already being localized. So here we can just format actually. Yeah, we can just do a format. Although, no, we can't just do a format. Because we want our string to equal the format of the incoming string. So it's like that. So it is the same as the format, except the string that's being formatted is the one that's coming in instead of the member itself. So we have our get string, we have our set string. We also want, operator overloads for a right-hand string. Where when we set it equal to just a string, we just say m string. Well, we want to actually first see if we're localized or not. If we're not localized, then we can set m string to a string, and then return this. And probably the same with the const char actually as well. If they're not localized, then m string can equal the string coming in. So, yeah, as much of a drop of a replacement for string as possible. Meaning we can also have a no discard operator for returning a const string as well. This is an implicit conversion to a string. So, like with the with like smart pointers, you can just check if a smart pointer is true or false, or if it's valid, just because they override operator boolean instead, and then just return get string. So this is just that, but except for strings. It's saying a non-explicit conversion operator. I don't really care. I also just want to say set string instead for these things. And string does implicitly, it does have a constructor for const char, so I don't even need to have my own. But that's fine. So there we go, that's that. We can also set if it's localized or not. And if we don't localize, then we can set the ID to -1. If we do localize, then obviously we need to call something else to actually localize it. So there's that. Obviously, this is just a header only thing because there's so many like templates going on. It doesn't have to be header only, it could be source file like these getters and some of these setters and things like the operators and stuff. Although, yeah, I think I'm just going to leave it as a header only thing. I also want to have a an OStream operator thing where we take a const locale string. You can obviously return stream, but we want to say stream pipe into the lock string dots, and I think get string can just, yeah, I can just say get string. pipe into that. Actually, yeah, no, I'm going to have this in the CPP file. Yeah, I will use the CPP file. Yeah, just because it is like genuinely a lot easier to just look at this instead of looking at the definition as well. Especially because you don't care about the definition in the header. There you go. And then I'm also going to have a macro for tails lock string, which just takes a string ID, has variable args, and just creates a tails locale string. Gets localization, we do the hash. We hash the string ID. Then we take our variable args and we do that. So for example, if I did tails lock string, we can just say, the ID being play game. And now this will just give us a locale string object with, the hash set, meaning the string is set. We have the hash coming in, we have the variable arguments. That's why we have this constructor here. So we can format it and all that. So if we did want to have this, we can say, play game, and then say, name. So if our play game, for example, had a name argument, there's a thing over here. Play game, that or something, right? Then we would have play game name. So that's, that's what that macro does. It's kind of like the Unreal Engine text macro. Yeah, I think it's quite cool. But we could just say lock string and it will just kind of have an easier look to it than creating this and doing the things. So there you go. And then that also means in our text class, in our widget text here, instead of having a SF string, we instead can have a locale string instead. Yeah. Like that. And obviously, a single string means it's not localized. This is not localized. This is localized. These two are, they just depend on whatever the thing is. This is currently not localized and stuff, so, it's all sick. Obviously, these functions are going to be a bit naff. Yeah, we can convert from SF string because the SF string has a conversion to STD string, and this has a conversion from STD string to this locale string. But yeah, we can just have a locale string there instead. This can be a locale string, and this as well. Also, don't need to make any of these const. These are all const. The getters are const. I think everything that needs to be const is const, I think. So that's all good. Yeah. This can also be a locale string. Also, if I quickly do tails lock string, just do like test or something, this will just be, actually, yeah, no, this will be a hash, meaning this is creating, this will always be creating a localized string. Yeah, meaning if you yeah, even if you didn't want a localized string, it'll always be creating a localized string. If you just wanted to have this object without it being localized, you would have to create it yourself, which I think is just fine. Yeah, obviously I can move it because I have the move constructor and stuff set up. So that means that this constructor you can just put in quotes. So if I wanted to make a W text here, say test, I can just do that. Obviously, set a character size and stuff, because we have a const char conversion to the locale string. So, you know, it all works quite nicely. I still haven't got the text drawing, because I actually don't know how to do that. I'm probably going to do that in my own time off video. This video's going to be really long as well. It's going to take ages to like edit. But yeah, that's did a lot of cool stuff. Thinking I might make a Tails specific exception class, just because why not? Yeah, I'm going to do that just because why not? It's good with fun. So we can say Tails engine include exception. Yeah, I don't need a source file for the exception because it's only going to have a. It's not even going to be anything interesting. Actually, no, I probably should have a source file for it. I probably should. So I want to include the exception library from C++. Extend, I think it's runtime exception or something. What does SFML do? Runtime error from std accept. And this just has a constructor which wraps the runtime error constructor. Okay, so he's saying implicit default constructor is not available. So let's see, we need a string bullet message. Just say std runtime error message, because the runtime error has a string constructor. So let's make it explicit. There we go. Okay, now I want to go back to the SFML one as well, because it's explicit is public. Yeah, okay. It's public, all that, cool. So that's all good. We have an exception thing. Nice. But make sure it works still. No, okay. Piece of undefined type. Something. So the string view is complaining. Cannot be used before it is initialized. You cannot do reference an operand of type int. So, oh, okay, it's because I'm trying to loop through this while my string doesn't define the correct things to be able to loop through it in a range-based for loop. Let's look up how to do that then. How to make custom type work in range-based for loop. So standard has been changed since the question posted. Life for to extract now one or two ways. Create a member, begin and end. Return something that acts like an iterator. Create a fee function, begin and end that returns something that acts like an iterator in the namespace of your typex. It's similar for const variations. Okay, so what does SF text do? SF string, not text. We have an iterator, which has that. Okay, so yeah, I can just return the std string iterator, right? You can have, using iterator equals std string iterator, and then using const iterator equals the std string const iterator. So then I can just make begin and end things where we return iterator, begin, return std string, return m string dot begin. Iterator end, return m string dot end. These are no accepts, but I'm sure it's fine. We can also do const ones as well, I think. Yeah, I think having the array thingy would work as well. That we can say size t index. Just return m string at index there. Can make const, obviously. We can have a non-const version. Why would you ever have that though? So then we also have in here the size. That's a good one to have as well, because we're wrapping it. We can say size t get size. It's empty or not, that's not a good one. Arrays, insert, find, yeah, I don't care about those ones. Get data is just going to be a pointer to the characters and stuff. Yeah, so we just have const versions of them. Okay, cool, so that should be able to work in the thing now. Yeah, we have a character, and that's all good. Just realized this should be under sales API as well. I'm also going to have a get data function. Okay, let's just make it a bit readable. There we go, a bit more readable. Okay, so we fleshed it out a bit more. We have support for range-based for loops. Still, string view is complaining. Doesn't say what line in my code is the problem. I don't think. It's just pointing me to the standard. Which doesn't really help. Use of undefined type. Okay, maybe it's just because I haven't included like host stream or something. Or IO stream. Yep, okay, that was the issue. It's because I hadn't included IO stream. Can I include it in here instead? Yes, okay. Well, there we go. That's been sorted. Very nice. So we have our own locale string class, which can be localized. Localization singleton, which will just hold a specific like localization thing. And yeah, that seems pretty good. Text doesn't work still. Not that I'm even testing at the moment, but yeah, have our own exception which can be thrown for constructors and things. Okay, cool. Thanks for watching. I think that's all I want to do. Yeah, I did audio. I did some audio effects. I do want to do audio stuff as well, but that'll be later. Animation stuff, that'll be later. I can do that next time. Loading, yeah, working out the level, like file things, can do that later as well. So that is that, pretty much. So thanks for watching, I suppose. It's probably been very long, but yeah, I'm gonna push this to get up now.